Okay, just nice there are people who just entered. Okay, my apologies. Okay, so let me continue. So a warm welcome to OVERMUGGED and also a warm welcome to this WA1 Online Revision. This is the online revision class for secondary for E-Math, that is for set notation and probability. Okay, so just a brief introduction of myself. So my name is Yule. Some of you are my students, whereas some of you are not. And also some of you are new. So just introduce myself. So for me, I teach all levels of math at OVERMUGGED. So perhaps currently you are an e-math student. So, if you are interested, like I also teach A-math, and also subsequently, if you do proceed on to JC, I do teach H2 math as well. So then below are some of my information. So I'm currently a final year student at NUS studying economics, and I have been teaching math at these various levels since 2017. So actually, I have been teaching since I graduated from JC. So if you do count the number of years, like from back then when I guess I was 19, yeah, and then you can probably guess my age now, right? And it makes sense as to why I'm graduating from university soon. Okay, and just some academic achievements of my students. So in the last 2 years of the examinations, all of my students achieved A. So I mean, before that, it's not 100% lah. So it was something between 80% to 90%. So but I'm quite happy to see that all of them have achieved their A's in the recent years. Okay. So for those who are new to OVERMUGGED, just like a brief overview of who we are. So we offer secondary IP and JC tuition, and we have taught more than 5,000 students, and we're located at 7 branches across Singapore. Those of you who are not in our Telegram group, you probably will want to join it. So the Telegram group links are definitely available on our website. So just click on it. So I think it is good to join because there are sometimes we have different revision sessions, WA1, WA2, etc. You'll be able to get access or you'll be able to get the first sign up, okay, if you're in the group, so that you're notified of all these events. The other thing that's also sometimes we have some non-academic, non-tuition related events. So we have sharing sessions from our alumni, which JC to pick, which university course to pick, etc. Study tips as well. And sometimes we also have free giveaways. So recently we have this iPad giveaway. Yeah. Okay. So I do encourage you to join them. Whether or not you're an OVERMUGGED student, I think it's still there's no harm in joining the group. It's free anyway. Okay. Next, for results for OVERMUGGED as a whole, for the whole tutor team, 70% at OVERMUGGED achieve distinctions at their national exam. So I mean, you might think that 70% may not be to your expectation. It could appear low to you. But of course, if you have information from your schools about what the distinction rates are, okay, for example, for E-Math, for instance, it is more often than not lower than 70%. More often it is about 40 to 50% only. Okay, so our tutor team is there are a variety of tutors, so with different teaching experiences and different education backgrounds. Okay, so you can be rest assured that for example, me, I'm teaching you math. I have experience in teaching math for 7 years, and my university degree, which is economics, is mathematics related as well. Okay, and next thing, if you do choose to sign up with us for our regular classes, we have consistent resources, and you also can make use of our centers to study whenever you like to. Okay, so perhaps after school, you want a place to sit down to do your homework, you can always drop by at Overmug to do so. Okay, so as mentioned, these are like our resources. So we have notes, we have revisions, okay, we even have mock exams. So this is quite surprising to some of you, I guess, like especially with the removal of mid-year exams. So like we have like mock mid-year exam, like this is quite popular in recent years. Okay, and if you are enrolling in science, we also have practical sessions. This is also quite surprising to many students because like they will think that a tuition center like us, we only have like maybe the theory part of things, right? But we also have the apparatus and the chemicals for you to perform experiments. So we also have like mock practical, like before the actual practical. Okay. Also, our tutors offer after class consultation. So like, they are just a text away, or like I'm sure like if you really have burning questions and you actually want to schedule a Zoom meeting with them, we are really happy to do so. Okay, I mean, some of them might have busy schedules, but for me, I would definitely be willing to do so at least. Okay, okay. The last thing is that today's A1 session, if you felt that you have benefited from it, like you it was a great revision for you. And also the questions that we are doing were able to actually check your understanding. It was great for you. You can leave a review. I will show this QR code again at the end of this session. So not to worry if you did not manage to scan it like now, okay? I mean, you're definitely not going to scan it now anyway, right? Because the session has not started, okay? So don't worry, I will show this QR code at the end of the session again, okay? So I will show this again at the end, but I will just like quickly flash it, okay? Like as to what our regular classes look like. So these are Sec 3 classes, but I don't think it is relevant for any of you here. So Sec 4 definitely is relevant for most of you here. So I will just like maybe flash the screen for like 10 seconds each for you to have a glimpse of what the classes look like. Okay, so that is all for the introduction. Let me just check whether new students have entered. Yep, so sorry because like from time to time I will check the waiting room. Yeah, but I may miss students out. Okay, so but I really apologize. That is obviously like not my intention to miss students out. Okay, and for the new students who just came in, I have to send the material again. Yeah, because I'm very worried that the new students, they always have this problem. Like when they come into the room, right, then they don't see the previous chat history. Okay. Okay, so I think we're good to go. For those of you who are already in the room for a long time, please open the worksheet. If you like have it on your like digitally, okay, you can either like if you're using an iPad, you can write on it. You can also use a foolscap paper to write if you are not using an iPad. Of course, you also have the option to print it out if you have time, like just 1 minute, just run to the printer and print it. Okay, it's your choice. Okay. Again, today we are doing the topic of the set notation and probability. So it is 2 topics, so there are a lot of things. And we only have about 1 hour and 10 minutes left. So I will try my best to cover. Okay, the concepts can definitely be covered. My only issue is whether the questions I can finish it, okay? But not to worry, like if I don't finish the question, it should be like very little of them left, and you can always try them yourself anyway, okay? And okay, we can get started. Okay, just give you about 10 more seconds to get ready. Okay, so how the structure of this will be run is that we'll be going through set notation first, and then probability. So for set notation and probability respectively, we will first start by going through all the concepts that you need to know, followed by the questions, okay? And if you just have a very like quick glance of the worksheet, so for the concepts wise, I will only be going through like the theory, okay? So there are some work examples like in this concept section that we will not do. Okay, what we will do for today is actually the question section. So for example, for set notation, it is section 3. Okay, we have 6 questions in total, 3.1 to 3.6. Okay, and that is when we move on to probability, where we will also go through the concepts first. Again, there are some work examples here, but we will not go through them. We will just jump straight to the section 4 for the questions. Okay, and again, we also have 6 questions here, 4.1 to 4.6. Okay, so as I mentioned, if you just do a very quick glance of the questions, you will see that I actually included every question type that you need to know. Okay, so I guess it's also like not a random throw of questions like that I selected from like somewhere, all right? Okay, it's actually curated based on everything you need to know. So for example, if let's say you got this question like wrong, or you were stuck, you actually are able to identify what concept in particular that you are lacking in, and you can practice more questions on this particular concept. Okay, so that's why I hope that this short revision session will be very beneficial for you. Okay, so let's get started. I will go through very quickly because I assume that you have already covered this in school. I mean, you should definitely have covered this in school. Okay, so we start with section 1, which is the terminology used in sets. Okay, so we'll just look at these bullet points very quickly. So what is a set? Okay, a set is used to describe a collection of objects. So these objects, they are actually called like more formally elements of a set. Okay, so we have set and we have elements of a set. Okay, a set should be denoted using capital letters. On the other hand, the elements of a set should be denoted using lowercase letters. So this table gives a very good summary. In the first row, P is an element of set S. So you can see that P is in lowercase because it is an element, and S is in uppercase because it is the set. Okay. In the next row, Q is not an element of set S. Okay. So if you were to zoom in at this table, you also need to know what these two symbols mean. Okay. It's the element of, it's not an element of. Okay. Lastly, we have NS, which is the number of elements in set S. So pay attention. This is the N. This small n is used to denote number of elements. Okay, moving on. So there are a few ways to describe sets. What we commonly see is the first and the third case. So like in the first case, you actually are listing all the elements in this set. So in this situation, the set A contains the elements 1, 2, 3, 4. And there are a total of 4 elements in set A. Okay, next, we could also give the set builder notation form. So here, I'm just telling you that the set A contains the elements X, where X are prime numbers between 0 and 20. Okay, so nothing difficult here. Let's continue. Okay, section 2. We have to know the 8 different types of sets in our syllabus. Okay, so there are 8. Okay, we look at them 2 by 2. Okay, so the first 2, these are called equal sets and empty sets. Okay, these are very simple. So what is equal sets? 2 sets P and Q are equal if they contain identical elements and the same number of elements. Okay. So I think this is intuitive, as in what does it mean for things in general to be equal, right? So they contain exactly the same elements and exactly the same number of elements. Okay, there's a quick note here. The order of elements may be different. Okay, this is just like a small note in case some of you are confused. So for example, if we look at this quick example, like if you can fill in the blanks, if P and Q are equal sets, okay, so P equal Q, we should be able to find out what the missing elements are. So what is missing in P is the element 12. And what is missing in Q is the element 8. Okay, so you can see that the way the elements are listed from left to right are not the same. But it doesn't matter because these sets contain the same elements and the same number of elements. That is the only thing that matters. Okay, the order in sets doesn't matter. Okay, you can write it wherever you like it. Okay, so moving on, we have the empty set. So empty, as the name suggests, does not contain any elements. Oops. Okay, and you need to know how to actually write it in set language. So in set language, you actually write this. Okay, you either write the curly braces with nothing inside, which makes sense, right? There are no elements, or you write a circle with a diagonal cancellation line. Okay. Okay, let's move on. Okay, the next 2 sets, okay, we use a Venn diagram to illustrate. So I think it's quite like easy to understand here that we have the set A, which contains the elements 1, 4, and 9. Okay, so it's in this circle. And then there are also some other elements that are outside of A. So these are 2, 3, 5, 6, 7, 8, and 10. Okay, so here we introduce the universal set, which is the set of all elements considered for this particular solution. It is represented by this symbol. Okay, so in this example, the universal set contains the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, basically all elements that you will consider for this question at hand. Okay. All right. Next, we introduce the complement of a set. So in this case, what is the complement of set A? Okay. So the complement is the set of elements that are in the universal set, but not in A. So you can think about it as like whatever that is outside of A, whatever that is not A. Okay. So this also has a set language that you need to know how to write. Okay. Here. Okay, this we call A apostrophe, or we more commonly call it as A prime. Okay, so in this example, there's a typo here, so let me just correct it very quickly. Okay, in this example, the A apostrophe or the A prime will contain the elements 2, 3, 5, 6, 7, 8, and 10. Okay, let's continue. Now, we introduce the next two types of sets, and we have another Venn diagram here. So we introduce what we call a proper subset. Okay, so what is a proper subset? Okay, so from the example above, you can see that every element of Q is an element of P. Okay, why? This is because Q is inside P. Okay, so 1, 5, and 9, they are elements of Q. But since Q is in P, the 1, 5, and 9, they are also elements of P. Okay, so this is true. However, the set Q is not the same as set P, right? Because the set P also contains extra elements 3 and 7. So what do we call it? We say that Q is a proper subset of P, and we write this in set language. Okay, so let's press on first. I will do a quick summary of this proper subset versus subsets later. So what about subset, which is the next concept here? So let's use an example to illustrate. So consider the set A, which contains the elements 6, 8, and 10. Okay, so we have just learned what is a proper subset. So I'm sure that if you are asked to list the proper subsets, we can do so. So let us do it in this table. So we have 6, we have 8, we have 10, 6, and 8, 6, and 10. Okay, 8 and 10. Okay, as well as the empty set. So whatever I have just listed, they are all proper subsets of A. Okay, again, what is a proper subset? Every element of Q is an element of P, but they are not the same. Okay, they are not equal sets. Okay, so whatever I've listed, okay, they are definitely not the same as A. Okay, but they are called proper subsets. So then it raises the question as to what is a subset. So C is a subset of A. So let me just illustrate first, then you understand in a bit. Okay, so for now, we are just copying everything that I've already written. Okay, but we also have to have 6, 8, 10. So I think it is already very obvious that what is a subset? Every element of C is an element of A. Okay, however, it is possible that they are the same. They are equal sets. So it is possible that C equals A. So in set language, we say that C is a subset of A, and we write this. Okay, so I know that some students, they still cannot wrap their head around these two concepts. But if you think about it, it's quite simple. For proper subset, they cannot be the same. So you can think of it in inequality sense, right? Okay, I mean, it's wrong mathematically to think this way, but you can think about this informally, that Q is less than P, right? It's strictly smaller, they cannot be the same. Whereas for subset, they can be the same, right? So if you see here, they can be the same. So smaller than or equals to. Okay, So informally, we think about it this way, and it also helps you to remember the symbols as to why for proper subset, there's no like double lines. But for subset, there is a double line, right? It makes perfect sense. Okay? Okay, 10 seconds before we continue. Okay, let's continue. Lastly, we introduce the intersection of sets and the union of sets. So, what is intersection? So intersection is just the set of elements which are common to both A and B. And it is denoted as A intersect B. So the curly N. Okay. So in this case, what is the commonality between A and B? It is the elements 2, 4, and 6. Okay. Next, union. These are the sets that are of elements belonging to A or to B. A or to B. So, by the way, in math, when we say or, it also means or both. Okay, like this is implied. Okay, whether I write it or not. Okay, so this is denoted in set language as A union B, so like the curly U. So in this case, it is just whatever that is in A or in B or both, right? So everything. So in this example, they are the elements 1, 2, 3, 4, 6, 8, 10. Okay, so just a food for thought. So what about the set that contains 5, 7, and 9? Like, how do we write them? Okay, so there are two ways to write them. Actually, some students don't know that there are two ways. Okay, so let me just very quickly write them here. So we can write this as A union B, right? But is not or is outside of this. So we prime. Okay. Alternatively, A prime intersect B prime. Okay. So this one is the same, like they both refer to the set that contains 5, 7, and 9. Okay. Okay, 10 seconds. Okay, let's continue. So this is a summary of the 8 different types of sets that we have covered. You can read them yourself. And also these are the common mistakes. You can also read them yourself. Okay, we move on to the questions now. So how we are going to go about this is that I will give you all like 1 minute to try like the questions, and then we will go through them. Okay, so 1 minute. Okay, let me admit like students if there are. My apologies here. I am only one person. If you have time, can you repeat A prime union B prime? Okay, let's just do it very quickly. There is no A prime union B prime. It is A prime intersect B prime. So like, these are just two alternative representations of the same thing, which are representing the set containing the elements 5, 7, and 9. So I am pretty sure that this one, people can get. Okay, I have already explained. So I'm talking about this 5, 7, 9 now. Why is it so? Because A union B is the blue region. But I want outside the blue region, so that is the prime here. Okay. So what about the second interpretation? This one is a bit harder. Okay, so let me just go through this. I'm sure some of you may also have question here. So to do all intersection problems, we will do like one by one, right? So we will do the A prime first, and then we will do the B prime, correct? And then intersection is what is common to both, correct? Because remember intersection, what is common to both, okay? So let's do it one step at a time, starting with A prime. So where is A prime? Let's do the shading. A prime is whatever that is outside A. Sorry, my bad, wait. Okay, so whatever I've just shaded in blue is A prime, okay, whatever that is outside of A. Next, I will shade B prime, whatever is outside of B. Correct? Okay, so intersection is just what is common. So if you can identify which region has the blue and red at the same time, okay, it will be the ones outside. Okay, 5, 7, and 9. So like I just do a very quick erasing. So here there's only one line. Here there's also only one line. Okay, here also only one line. Okay, here also only one line. Okay, hope that answers your question. Okay, just 10 more seconds in case some of you who are listening did not try this. Okay, so just to like let you all know, these questions are like not very difficult, right? They are meant as a revision. Like if you don't know to do, then you should be worried. It's not meant to kill you. Okay, so let's go through this question. It is given that the universal set contains x, which x is an integer between 1 and 15, excluding 1, including 15. A is a set containing the x, where x is an odd number, and B is the set containing the x, where x is a multiple of 3. So, for all questions, it's always good to list down what are the elements in these sets. So for the universal set, it is very simple. It will be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Next, we have the A. So again, the universal set actually constrains what you consider. Because if not like A, right, it's the odd number, right? Then you will list all the odd numbers in this universe, right? So that is not the case. You can only consider whatever elements that are listed in your universal set. So the universal set is very important, okay? So in this universal set, which are the odd numbers, okay? We have 3, 5, 7, 9, 11, 13, 15, okay? Very easy, okay? B, multiples of 3, okay? 3, 6, 9, 12, 15. Okay, so due to space constraint, let me write at the top. Part 1. Write down A intersect B. So what are the elements here? Okay, you just need to see what is common. Okay, remember again, intersection means what is common to both. Okay, here and here, what is the commonality? Okay, it is not difficult to see that it is 3, 9, and 15. Okay, part 2, write down A prime intersect B. So of course, for students who are like a bit weaker, you can definitely list down like what A prime is, right? Like if you really want to, okay, you just write whatever that is not in A, okay? But for the faster students, like remember intersection, right? You consider one by one. So here we can actually consider B first. So B contains the 3, 6, 9, 12, 15. You just need to write down out of the 3, 6, 9, 12, 15, whatever that is not in A. That is our answer, right? Think about it. You consider the B first, which is 3, 6, 9, 12, 15. But we need to intersect the A prime. So that means what out of these 3, 6, 9, 12, 15, which one do not appear in A? Okay? And it should be quite easy to see that the answer is 6 and 12. Oops. Okay. Okay, so for those who are already good, you can move on. Okay, but due to time constraint, let's move on to 3.3. Okay. So 3.1 and 3.2 are the same question type. So that's why I never like we can just skip it. Okay, the only difficulty with 3.2 is I have the introduction of 3 sets. So you can definitely try them. Okay. Okay. So try 3.3, word example 3. Okay. So I think it's about time. Let's go through. So on each of the Venn diagrams, shade the region represented by the set notation. Okay. So here is a very good, because this is like many students are very weak here, especially when it comes to 3 sets. Okay, so part 3 will be a good like checkpoint for you. Okay, so part 1, A union B prime. Okay, so just a recap again. If it's intersection, it is what is common to both. If it's union, it is whatever that belongs to either one of them or both. So union, you can take a lot of things. Okay, that is the point here. Okay, so regardless whether it is the intersection or the union, we can do it one by one. Okay, one by one, what do I mean? So for example, like you can do the A first, then you can do the B prime, okay, etc. Okay, so let's do the A first. So A is whatever that is in A is you shape the entire A. Okay, next B prime, you must shape whatever that is outside of B. Okay, and this is union. So union means we take. As long as got some shading, we take. Okay? It doesn't have to be like multiple shading. That is referring to intersection. For union, as long as you shade, you take. Okay? So the answer is as long as you shade lah. Okay? Okay? Okay. Part 2, B prime union A prime holding union. Sorry. B prime union A prime holding prime. Okay? So let's do it one step at a time. We can definitely work out this first. Okay, B prime union A prime. Again, this is union, and as for all questions, we do it one by one. So let's do B prime first, followed by A prime, followed by the prime. Okay, so B prime. Okay, where is B prime? Whatever that is outside of B. Okay, union A prime, A prime. Whatever that is outside of A. Okay, wait, sorry, let me shade again. Okay, whatever that is outside of A, right? Yeah. Okay. So if we just consider the terms inside the brackets, B prime union A prime. Okay, it is whatever that I have shaded. And again, union means as long as you shade is okay, correct? But this is not the question. The question is the prime of whatever that I have just shaded. And therefore, the answer is whatever that I have not shaded. Okay, that is here only. Okay. So step by step. Okay, there's no rush to this. Okay, let's go through the part 3. Okay, part 3. A union B prime holding intersect B. Again, step by step. Okay. This intersect this. So we do left side first, then we do right side. And for the left side, we do this first, then we do this. Correct? So step by step. Okay. In general, we apply the Bodmer's rule, like, like sort of right here, where we evaluate this first, the terms in the bracket first. Okay, in case you're wondering, it got union, it got intersection. Which one first, right? Bodmer's brackets first. Okay, so A union B prime. A, where is A? A. This is easy, right? Okay. Union B prime. Where is the B prime? Whatever that is outside of B. Okay. So whatever I've shaded, again, this is the union of A and B prime. So as long as I shade something, I'm referring to that. Okay? Now, I want to intersect B. So this is where I think when we have three sets, right? I do not think you need to shade like, like for example, like this. I mean, I think it's very messy, but if you want, you can. But I think here it's still quite simple to do it. So we can do it. But you can think about it as like there's also another way, which is instead of shading another time. So whatever I've shaded currently is A union B prime. I just need to check which one is also at the same time in B. Because intersection, right? So I need to also common to both, common to green and blue. So what is also in B? Correct? Whatever I have shaded, which one is also in B? Okay, it should be natural that it's only this part. So this is what I mean. I don't really need to shade another time. Okay, out of whatever I have already shaded in the blue and red, okay, that's the left-hand side. What is also commonality, okay, to B? So I don't need to add in lines, okay, it's clearer. But if you really want to add in lines, sure, okay, B, right? B or just shade the B lor. Okay, I just think, especially if it's very complicated, it can be very messy. Okay, the answer is also the blue highlights. Okay, if those who are done, we can move on to 3.4, word example 4. I'll give you about 2 minutes to do word example 4. Okay, let us go through. So it is given that the universal set, okay, contains the elements, the integers between 1 and 12, including 1 and 12. P contains the elements that is a factor of 12, and Q contains the elements that's a multiple of 4. Illustrate the given information using a Venn diagram. So before that, it is always again helpful to list out the elements first. So let's do that. So in the universal set, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 11, 12. In the set P, factors of 12, remember you must always refer to only your universal set. Don't come up with all the factors of 12 or all the multiples of 4. Okay, so for the set P, it should be 1, 2, 3, 4, 6, 12. Yeah, for the set Q, it should be 4, 8, 12, right? Okay, Venn diagram. So draw this Venn diagram. Remember to label this universal set symbol. Okay, so PQ. Okay, so here if we do the labeling, what is the intersection between P and Q? We have the elements 4 and 12. Okay, then there will be 8 here. And then there will be 1, 2, 3, 6 here. Okay, and then 5, 7, 9, 10, 11 will be outside. Okay, so just a word of caution, because I will be skipping word example 5. Word example 5, the Venn diagram, there is also Venn diagram, okay, but it's the same, so I skip it. But it's quite interesting there because the Venn diagram there that you will draw is actually not like this, okay? The Venn diagram that you will actually draw there is going to look, okay, give me a moment, it's going to look like this. Okay, just draw the set very quickly, like, Okay, so remember the proper subset. Okay, so that's a bit harder to do, right? Okay? That's less common. Okay, so my point here is that this is a very easy question, but 3.5 you can try yourself later. It's a bit harder. You're gonna be looking like this. Okay. My point is that when you're asked to draw a Venn diagram, don't be so excited to draw this. Because only if there is the intersection and only if there are extra elements, like for example, that is in P but not in Q, in Q but not in P, right? Then you can draw this one. If it could be this case as well, right? So you need to think carefully. That's why it pays to list the elements first. Don't be so excited to jump to the Venn diagram. Okay, let's continue to part 2. Hence, list the elements in the set P intersect Q prime. Okay, this should be quite easy. So let's do it. P intersect Q prime. Okay, this will be just 1, 2, 3, 6. So I guess, again, the skill here is to do the intersection, right? And to do it one by one, correct? So let's just very quickly run through it. P, okay? Let me use red color. P. Q prime. Whatever is outside of Q. Correct? So intersection just means commonality, right? What is common between red and black shading? Okay. It is here only. Okay, 1, 2, 3, 6. Okay. Okay, so we also call this, like, informally, the big crescent in P, right? This is the big crescent. Okay, like the moon, right? But the big moon, okay, in P. Okay? Okay. Lastly, let's go through part 3. Describe in words what the set P union Q holding prime represents. Oops. Okay, so let me just write the answer first. P union Q holding prime represents the integers that are neither multiples of 4 nor factors of 12. Okay, how do I know? Remember, step by step, right? P union Q is whatever is as long as it's in the circles, right? But I want the prime of that. So P union Q, as long as you are in the circles, you will definitely be either a factor of 12 or a multiple of 4, right? But because I want to prime this, correct? So they are neither the multiples of 4 nor the factors of 12. Okay? Okay? Okay, if all is good, if we are skipping 3.5, let's go straight to 3.6. Work example 6. Okay, so this I give you about 1 minute. Okay, for those of you who have questions on the questions that we don't go through, don't worry, you can ask like later. So I think for Hashika, Angel, yeah, you just stay back for a while later. We can run through that. Because the answers will not be uploaded on the drive. Yeah. Deepa, can we just write the numbers that are neither in P nor in Q? Oh, that is for part 3. No, because like we have to answer in context of the question. So like in words, yeah, okay. So contextualizing it rather than just like a very math way, right? Just PQ, okay, not in P, not in Q, like that, okay. So yeah. So I hope that answers your question for Deepa. Okay, we have to answer in the context of the question. Okay, 3.6. There are 27 children in the class. Out of these children, 19 own a smartphone, 15 own a computer, and 3 own neither a smartphone nor a computer. Using a Venn diagram, find the number of children who own a smartphone but not a computer. So this is like solving for a variable unknown question. Okay, So to solve this, okay, let's do it together. Let the number of children who owns both a smartphone and computer be X. Okay, that's what I was saying. So we draw a Venn diagram. Okay, but here it's a bit different. The Venn diagram, instead of writing the elements in the Venn diagram, we are writing the number of people or objects that are in the respective sets. Okay, so for example, we have the smartphone, and then we have the computer, right? So number of children who own both smartphone and computer be X. So this X is referring to the number of the objects in the set, not the element itself. Okay, please take note for this kind of word problems. Okay, so to solve this question, the key is to label all the regions. So 19 own a smartphone. Okay, 19 own a smartphone. So therefore, this region must be 19 minus X, correct? In totality, they add up to 19. Next, 15 on a computer. So same concept, 15 minus X. 3 own nothing. Okay, so how to solve for the X? We equate to 27 because the total number of children is 27. Okay, just do some like quick math. You should be able to get X equals to 10. Okay, but that's not all. This is not what the question was asking for. Number of children who own a smartphone, okay, but not a computer. So it should be here. The big crescent in S. Okay, so we are solving for 19 minus X. So number of children who own a smartphone, but not a computer. 19 minus 10. Okay, 9. Okay, the answer is 9. Okay, I give you about 30 seconds to just finalize things before we quickly move on to probability. Okay, let's move on to probability. Okay, so very quickly, because we are running short of time, it is a recap of lower set probability. So probability is just like the same as likelihood or chance, okay? They are synonymous, okay? So probability, likelihood, chance, right? These are all between 0 and 1. Right? So for example, probability of rolling a 6 on a fair die, okay, is only 1 out of 6, right? Because there are 6 faces on the die, but you only have one face containing 6. So 1 out of 6 is the probability, the likelihood, or the chance of rolling a 6 on a fair die. Okay, so it is definitely between 0 and 1, right? If it's negative, so what does that mean? You're so unlucky until you will never get and I don't know, to a negative spectrum, right? It's not possible, right? If it's more than one, then what does it mean? You are rigging the game, right? You can manipulate it. It doesn't make sense also, right? Okay, so probability is between 0 and 1. Okay, so we have this definition here for any event X. Px is the number of times event X can happen over the total number of possible events. And we also have the complement or the prime or the apostrophe here. Okay, Px prime is just 1 minus Px. This is the same concept as in sets. Okay, whatever that is not in X, right? They add up to give you the probability. The probabilities will add up to 1, right? Okay, just some notes in these properties. If it's not possible, the probability is 0, right? It's easy to understand. If it's definitely happening, the probability is 1, right? It also makes perfect sense. Okay, probability cannot be negative, cannot be more than 1. Okay, let's continue. Now, we introduced in this section 1 what we call mutually exclusive events. Okay, we do not have to run through this experiment. Let's just look at this Venn diagram. So if there are no overlap between the outcome of the two events, they are said to be mutually exclusive events. Okay, so for example here, we have the universal set, we have the A and the B. If you look at the elements, okay, there's nothing that is the commonality to A and B, right? A and B are separate circles. So this, in the context of probability, which we call events, these A and B are mutually exclusive events. Okay, and this is a property that you must know. It is not given in the formula sheet. If two events A and B are mutually exclusive, P of A union B equals PA plus PB. Okay, let us continue. Section 2, probability of combined events. So far we've only covered the probability of a single event. So like rolling a 6 on a fair die, right? It's just one time. But here we can calculate the probability of combined events. So maybe rolling a 6 on the first die and rolling a 2 on the second die, right? So sequential, okay? Or like there's just two things that you want to happen, okay? So there are two methods which can help us to visualize the possible outcomes. Okay, they are the possibility diagram and the tree diagram. Okay, so let me just write them down. Possibility diagram. Okay, and the tree diagram. Okay, possibility diagram is very useful if your two events they are happening at the same time. Okay, but you just want to visualize the combined outcomes. Okay, tree diagram is useful for sequential events. So one event occurs after the other. Okay, but it's still two events. Okay, so just like a quick, because we don't like have an example here. Okay, a possibility diagram. Okay, roughly it looks like this. Correct? Okay, and a tree diagram. Roughly it looks like this. Okay, to be fair, A possibility diagram also got another variation, depends on what the question asking you for. So it might look like this as well. Okay, so due to the interest of, okay, sorry, I have one more concept. Okay, we're all good. Okay, two methods here, the possibility diagram and the tree diagram. Okay, okay. Last section for the concept, the independent events. So what are independent events? Independent events, okay, if the result of one event do not affect the probability of another event, event A and B are independent events. Okay, English, it makes sense, right? Okay, if what happens in the first event, okay, it does not affect what is going to happen in the second event, they're not related, right? Yeah, so they are not affecting each other. They are not dependent on each other. They are independent events. Okay, uh, we also have a property here that you have to know it is not in the formula sheet. If two events A and B are independent, then PA intersect B equals PA times PB. Okay, so if you are good, we will skip work example 4.1. I think this is quite uh like simple. Okay, work example 4.2. We can do this. Okay, just spend 1 minute to do this. Okay, let's go through this question. A bag contains 16 balls, of which X are red. When four more red balls are added to the bag, the probability of drawing a red ball becomes 0.6. Okay, so what is the probability of drawing a red ball? Okay, and mind you, this probability that I am referring to is after the addition of the 4 red balls. Okay, I mean, honestly, if you want to do before the 4 red balls are added, you can also do it, but that is like not relevant to this solving. Okay, so like if you really want this is the O probability of drawing a red ball. Okay, this is just X over X plus 16. Okay, how come? Because it's just how many balls are red over the, sorry, my bad. X over 16. Okay, so how come it's like that? It's because your numerator is how many balls are red, and your denominator is how many balls are there in total. Okay, 16. Okay, but now we're talking about the new probability of drawing a red ball after the 4 red balls are added to the bag. So how many red balls are in the bag now? It should be X plus 4. Okay, how many balls are there in total in the bag now? Okay, it should be 16 plus 4. Correct? So this should be quite easy to see. So I repeat, your numerator is always the number of red balls, right? So after you put in the red balls, it will become X plus 4. Your denominator is always the total number of balls. So after you add in the balls, in total, that should be 16 plus 4, which is 20. Okay, so we equate this to 0.6 that is mentioned in the question. Okay, we do some quick math. X plus 4 equals to 12. Okay, X equals to 8. Okay, if you are good, you can move on to work example 4.3, the David question. I give you about 2 minutes to do the David question. Okay, last 30 seconds. Okay, let's do it. In a school examination, the probabilities that David will pass mathematics, English, and science are 7/8, 7/10, and 4/5, respectively. Part 1, find the probability that David passes English only. So probability David passes English only. Okay, so many students, when they look at this question, they have a tend to be tricked, because the probability that David will pass English is just 7/10, right? Then they, 7/10. Okay, but that is not true. Because if you want to pass English only, you must fail mathematics and science, right? Don't forget that. So you must multiply with 1/8 and 1/5. Okay? And the answer is 7/400. Okay? Part 2. Probability David passes English and science only. So same concept here. You must pass English and science. So that is 7/10 and 4/5. Okay? And you must fail mathematics. So that is 1/8. So here you'll get 7 over 100. Okay, part 3, find the probability that David fails exactly 2 subjects. Okay, probability that David fails exactly 2 subjects, it could be fail uh, math and English, math and science, as well as English and science. Okay, so we have to consider all 3 cases. Okay, so if you do the calculation, okay, your final answer here will be 1 over 10. Okay, let's go to the last part. Find the probability that David passes at least 1 subject. Okay, so here is easier to use the complement approach, which is what is the opposite of what I want here. Okay, you don't pass at least 1 subject. Means you fail all subjects lah. Okay, so 1 minus, if you fail all subjects, you will have 1 over 8 times 3 over 10 times 1 over 5. The final answer here is 397 over 400. Okay, I give you about 10 seconds to digest this. Okay, then we move on to the last question of today, which is 4.4 work example 4. Okay, I'll try to end at 1:40 p.m. Okay, let's go through work example 4. Bag A contains 3 blue balls and 7 green balls. Bag B contains 5 blue balls and 9 green balls. A ball is taken from bag A and placed in bag B. One ball is then taken from bag B. Given that the selections are random, find the probability that the ball taken from bag B is green. Okay, so here, probability ball from bag B is green. So here you can see that you have to consider two cases, right? Because depending on what you draw in bag A, whether it is blue or it is green, you will put this in bag B, right? And this will actually affect what is the probability that you draw a green or a blue in bag B. So this is actually what we see as a dependent event. Because what you take out of the bag A is actually going to affect the probability of whatever that you want in bag B. Okay, they are related. Okay, so here are two cases. So first one is, let's say, blue from A, green from B, plus green from A, green from B, correct? So blue from A, 3/10. Green from B, okay? So this is the more tricky part. So blue from A is 3/10. That is simple. Okay, that is here. But now for the bag B, we are putting this blue ball that we have drawn into bag B. So this means that there will be 6 blue balls now. Okay, but still 9 green balls in bag B. So green from B is 9 still, but it is out of 15 because we have taken the blue ball from bag A and put it inside bag B. So even though there is only still 9 green balls, but the total number of balls have gone up because of the blue increase. Okay, same thing. Green from A is easy, is 7/10. But now, green is going to become 10 green. Of course, we still have the 5 blue balls. Okay, so this will be 10/15. Okay, and the final answer here is 97/150. Okay, so let me just quickly just show you like what are the remaining questions. Okay, then I'll give 10 seconds first in case some students are still copying. Okay, so I'm just going to run through with you what is the purpose of work example 4.5 and 4.6. Okay, those are not difficult. It's just the two methods that we have discussed just now. Okay, I move on, yeah? So the work example 4.5 is just to use the possibility diagram, so you can try them yourself. It is not difficult at all here. And the last one is to use a tree diagram. Okay, so let me go back to the Zoom. Okay, so that is all for this lesson. I will show you all the QR code if you'd like to scan to give the feedback. Okay, here. Okay, the top review will receive a set of curated notes. Okay, so with this, we have come to the end of the WA1 Online Revision. So I hope you have benefited from this session. If you still have burning questions, you can always stay back. I will just be here for a while. Okay, if not, that's it. Okay, thank you for coming. I hope to see you around. Show you the tree diagram again. The tree diagram looks like this. Okay. Okay, so I'll just stay back for a while if there are still like burning questions that if you want, you can unmute yourself and also ask them because there's not much people in the room left. Okay, no problem. Okay. What are the elements of A in 3.5? Just give me a moment while I pull that out. Okay, no problem. Thanks for attending. Okay. So, the key here is just to solve this inequality. So, x less than 38 over 5. 38 over 5 is, if you use the calculator to press it, it is 7.6. Okay, so the elements in A, it must be considering the universal set, right? So if you take into account the universal set as well, it will only be 1, 2, 3, 4, 5, 6, 7. Okay, I hope that helps. So the key here is just to solve this inequality first. Okay, no problem. Okay, those who have no more questions, you are free to leave. I will just, why is it 3 over 10? Sorry, 3 over 10 for part 3, question 4.3, 3 over 10. So very quickly, let me just run through what each cases are. So the first one is you actually fail math and science. Okay, sorry, I was rushing for time, so I didn't explain this in detail. Okay, the second case is you fail English and science. Okay, and the last case is if you fail math and English. Okay, so you are failing exactly 2 subjects. You are just choosing which one you are failing. Okay, consider 3 cases. Okay, hope that answers your question. A. I mean, I don't know how to address you, but yeah, hope that answers your question. Okay, that's about it. Okay, no further questions. Thank you. Okay, let me stop the recording.